Hyperspectral images are large in size. In last couple of months, we were working on a project to develop the compression technique for hyperspectral images with Professor Miha Ivanovich. And I would like to take you through the steps that how this compression technique is done. So basically, it's first of all, it's a pixel-wise compression technique. It means we apply these steps per pixel. Firstly, the first step is to convert the signal from its domain to a frequency domain by applying a fast Fourier transform. And thus, we get a Fourier spectrum. And after that, we use the exponential function, negative exponential function, in order to obtain the parameters through this spectrum. Here in this part, we applied the function as it's described in the orange curve to obtain the parameters A and B. So A and B parameters are basically the compressed representation of the main image, and the size of these two parameters are just 3 megabytes in this case. And this was our basically one of the first experiment. So these parameters are just 3 megabytes compared to the original picture, which is 33 megabytes. So we approximately achieved the 11 times of compression. And after this, the compression process, in order to reconstruct the image, we do the reverse to use this A and B parameters with negative exponential function to restore some of the values, which values are used as an input to a neural network. So in our case, this neural network that we trained is capable of learning the correspondence between the exponential function and the final output, which is a hyperspectral image itself with full bands. Here are some results that we obtained. On picture C and D, basically this is a RGB version of the hyperspectral image. As we see, this is a lossy compression. We lost some information, especially it's seen on the colors of the roofs. And the picture A and B is a representation. They're 2D matrices. They were composed of parameter A and B that I described before. So we would like to show by these A and B pictures, we would like to show that there's a strong correlation between these parameters and the original picture itself. Also, we use some evaluation metrics to evaluate our results. I should say for a first attempt, it's quite promising that we achieved the low numbers in terms of color difference, mean absolute error, and the perfect value for the structural similarity index measure. But I should add that this is a very initial step for this project, and we would like to continue to improve the techniques. Thank you very much for your attention.